from the review? That's page, what, 2? Okay. All right. So the first thing that I'd want to do is I want to pick out my values for A, C, H, and K. So before I can do that, I have to check to make sure my equation is in that transformation form, which basically comes down to checking to see if the leading coefficient on X is 1 or not. And it is, so I don't have to really do anything. I can jump right into assigning my values or determining these values. So far, so good, Victoria? Okay. And then I'll write my transformation map. So that's going to be CX plus H, AY plus K. And then I'll go to my key points for sign. And we'll go plug the X into the X spot and the Y into the Y spot. When we do that, we get pi over 2, 0, pi and 2, 3 pi over 2 and 0, 2 pi and negative 2, and 5 pi over 2, 0. Okay with how I did that? Okay. So I'll go ahead and plot my points then. So I notice that each grid line is half a pi. So here's pi over 2, 0, pi and 2, 3 pi over 2, 0, 2 pi negative 2, and then 5 pi over 2, 0 again. And now I'm just going to kind of draw this in. And I'll go ahead and extend my graph in both directions. So after I go back to a maximum, midline, minimum. And same thing with the other end. I'd be down to a minimum and then back to the midline. So just kind of follow the pattern in both directions to kind of fill out the rest of my graph. Victoria, you happy with what we did there? Okie dokie. Ben?
Could you be on that one?
Sure. So it's basically the exact same idea. The thing that I need to make sure I observe, though, is that that isn't in factored form. So I'd have to start by factoring. So when I factor that 2 out, I get that. So my A is 1, my C is 1/2, my H is negative pi over 2, and my K is 1. So far, so good?
Yeah.
Okay. So I'll go ahead and write my transformation map. That's CX plus H, AY plus K. And I'll do that to the same key points. Since this is a sine graph, it's still the same key points. So here is negative pi over 2 and 1. And then we have negative pi over 4 and 2. Then we have 0 and 1. And then pi over 4 and 0. And then the last spot here we have is pi over 2 and 1. So I notice here that if I look at my x-axis, every grid line is a quarter of a pi, right? Half of a half is a quarter. So I have here then negative pi over 2, 1 would be like off my graph somewhere, like over here. Negative pi over 4, 2 would be here. And 0, 1. Pi over 4 and 0. And then pi over 2 and 1. And then I would just kind of continue extending this. So I'd be going up to the max, midline, minimum, midline, maximum, midline. And that's the rest of my graph. Does that feel okay, Ben?
Yeah.
Okay. Jane?
Could you do C on 3.1 question 5?
What page are we looking at? Okay. Fifth page, and you said C? Okay. So I would start by sketching myself a picture here. So I have a minimum down here, and then a maximum up here. And then I'm just going to kind of complete one full period. Okay with that? Okay. So the first thing I'm going to want to do is try to figure out what the midline is. So I know the midline goes halfway in between the two. So that's going to be halfway in between negative 12 and positive 8, which is like the median of those two numbers, like the number in the middle of them, which is going to be the same as the average. So I can just take those, add them up, and divide by 2. So far, so good? Okay. I remember that the amplitude is the distance from one of these extrema back to the midline. So the maximum was at 24,8, and our midline was at negative 2. So how many units does it take to go from 8 down to negative 2? That's?
To negative 2?
10?
10.
Right, we need 8 units to go down to 0, and then 2 more units to go down to negative 2. So 10 units, right? And I know the amplitude is the same as the absolute value of A. So we'll figure out whether A needs to be positive 10 or negative 10 in a few minutes. Next thing I'm going to do is come up with the period. So I know that one period is like from there to there, right? But what we have is just this section of it. How much of a period does that look like? Like a half, a third, a fourth, a quarter, 3/4? Half. You guys agree with that? Just looking at the drawing that we've made. So we're going to say 1/2 of a period is equal to, and that's going to be the horizontal distance. So the horizontal distance, how far is it from negative 6 to positive 24? Here's your redemption chance, Jane. How far is it to go from negative 6 to positive 24?
so early for this.
I know.
Sorry. I guess my brain is not working.
So to go from -6 to 0 is how many? Okay, and then from 0 to 24 is 30 total. That's all. Is that okay? Again, you could use your calculator to do that if you had to, but like, goodness gracious, we're just kind of counting. And just finding the simple way of thinking about it, right? Landon, you had your hand up. Were you trying to answer the 30, or did you have a question? Oh, okay. So then if I multiply both sides by 2, I get that 1 period is 60 units. Happy with that? And I know the period is 2 pi times the absolute value of c. So when I divide both sides by 2 pi and select the positive answer, I get that c is going to be 30 over pi. So my last step here, I need to decide whether I'm going to write a sine or a cosine function, figure out whether the a needs to be positive or negative, and then find the corresponding value for h. So Jane, for this problem, would we rather use sine or cosine?
Which is the one with the
Cosine. So we want to use cosine. Very good, because the problem here has mins and maxes in it. We want to use cosine. And you don't have to do it that way. It's just much easier if you do it that way. So we've chosen cosine. From the parent function, cosine, we're going to select the point 0, 1, which is a maximum. Anytime I'm using cosine, I want to use that point because the x-coordinate is 0. It makes my life easier. And now I can pair that with any extreme point from our problem. So do you want to use the minimum, -6, -12, or the maximum, 24, 8? It doesn't matter. Either is fine. Okay? And because each of these points is a maximum, what does that tell you about the value for A? It's positive. If we had selected the minimum instead, then A would need to be negative. And because the x-coordinate from our parent function is 0, what can we say about H? That it's going to be the x-coordinate from our transformed function, so 24. And that's everything we need. So we have y equals 10 cosine of 1 over c, so I'll just write that as the reciprocal. And then x minus 24 minus 2. And you guys know we can check these problems with our calculator, right? This is perfectly reasonable to do. So what I'm going to do to check this is I'm going to take the equation, my answer, and I'm going to plug in the x's from my 2 points that I'm given and make sure that it gives me back the y coordinate for that point. So we had 10 times cosine of pi over 30 times parenthesis x, so I'll write -6, minus 24, close my 2 parentheses, and then minus 2. When I do this, though, you need to make sure your calculator's in radian mode, worth pointing out. If you're in degree mode, it will not work out for you. And that does give me -12, like I wanted it to. I should check the other point also, though, because it's possible one to work and the other could not work if you'd made a mistake. So if I change that to 24, I get 8. So I'm quite confident that I've done this correctly. Now, that's a nice check because it certainly identifies to you if you have a problem, provided you can type this in your calculator correctly. It doesn't do a great job of telling you what the problem is, but if you made a mistake, say like finding the period or like finding the H, or your A value is negative instead of positive or whatever, you would not be getting the right answers for this. So it's nice in that regard. Maria.
How do you change the absolute from the radian?
Oh, so if you just press the mode button, the third option there is degree or radian. So you just move your cursor and press enter to make sure that your desired mode is highlighted. Yeah, and then you can just press second in mode to exit back out. No problem. Victoria.
Could you do next one?
Sure. So I'm going to start by drawing a picture. So I'm going to start by drawing the midline since I have a midpoint here. It probably makes sense to start that way. And so there's my midpoint that's on the midline. And it says the next extreme is at 15, negative 13. Now I can tell just by looking at the y coordinates that this point is a minimum because negative 13 is less than 2, so it has to be below it, right? So there's that. And then I'll draw in the rest of my period here. So that's like the rest of my period. Is that okay?
When it says like midpoint at that point, isn't that like a point or is that like on the line?
Well, it means that point is on the midline. So it's telling you the location of that point. And really, it's telling us the location of the midline also, right? For free, that the y coordinate here is going to be our k. We don't have to do any calculation there at all. Since the midline has to go through that point and it's a horizontal line, we know then, well, the y coordinate there has to be the k. That's nice. The next thing we'll do is we'll come up with our amplitude. So again, that's the distance from the midline to an extrema. So if we're starting at 2 and we're going down to negative 13, how many units did we cover there? 15, right? We go 2 units down to 0, and then 13 more units down to negative 13. So 15 units are covered. Sound good? Okay. The next thing we'll do is come up with our period. So this is one full period that we drew in. And this is the part that we know about. How much of a period does that look like to you? Okay. So that's midline to extrema, right? So we have another extrema to the midline, another midline to extrema, and then another extrema back to the midline. So how many of those sections did we have? 4. And what we have that we know about is one of those 4 sections. So how much of a period would you say we have? 1/4. Does that feel good to everybody? And again, the period is the horizontal distance. So you're just looking at the distance between 7 and 15, which is just 8, right? Okay with that? So then I'll multiply both sides by 4 to get the period by itself. And I know the period is 2 pi, absolute value of c. So when I divide both sides by 2 pi and select the positive answer, I get that c is 16 over pi. The last piece here now, we need to decide whether we're going to use sine or cosine, figure out whether our a should be positive or negative, and then find the corresponding value for h. So Victoria, which one would you want to use in this situation, sine or cosine? Okay. Would cosine also work? Yeah, because we have a midpoint we can use sine with, and we have an extrema, in this case we know it's a minimum, that we could use cosine with. So either is fine, but you said sine, so let's use sine. So from sine, we're going to use the point 0, 0, which is a midline that is followed by, or is a midline point that's followed by a maximum. Which point from our problem do we need to use? I'm sorry, what? I have to use 7, 2, because I've picked sine. So I have to use the midpoint. So in our problem, we have our midpoint here at 7, 2, and immediately to the right of that is a minimum. So this is the midline min version. If I compare these two, what can I say about A? Has to be negative. Everybody's okay with that? Since they're the opposite kinds of midline points. So the A we said in this case was 15. Okay. So negative 15. And then the H has to be, since the x-coordinate on the parent function is 0, it is 7. And that's everything we need now. I think it's 2, right? Yeah. Again, in the keys or whatever, I often listed multiple correct answers depending on what stuff you use to get your answer. On the test, one answer is sufficient. You don't need to list like all of them. Oh boy.
Can I say something quick?
Sure.
For my calculator?
Go ahead.
I wasn't getting, for the one that, the problem we did before, I wasn't getting 8.
Okay. So this sounds like something that you and I just need to look at your calculator in a minute.
Okay.
So I can go over and like see what you typed in and figure out what's going on. But just save whatever the last thing you typed in was so I can see that.
Okay.
And then you and I can take a look at it and I'll figure it out for you and show you what's going on. Does that feel okay? Of course. Ben?
Did you see B on this page? I know you.
Sure. So on B, we have a lot of free B information, right? Since the amplitude is 2, we know right away that the absolute value of A is 2. Since the period is 5 pi, we can say right away that 2 pi absolute value of C is going to equal 5 pi. So when we divide both sides by 2 pi, we get that C is just going to be 5 over 2. Because we always pick the positive answer there. And now we're going to decide whether we want to use sine or cosine. In this case, we want to use cosine because we have a extreme point, right? We're told the point in question is a maximum. So I'm going to use cosine. And we have to use the point 4 pi negative 2, because that's the only point we have. And we're told that's a maximum. Since both of these are maximums, what can I say about A? Positive. Very good. Since the x-coordinate in our parent function is 0, what can I say about H? Nope. Nope. That it's the x-coordinate from the transform point. So it's 4 pi. And now here's the tricky part, is going to be finding k. So notice here that the y-coordinate for my transform point is not, or for my parent function is not 0. So the k is not simply going to be the y-coordinate for my transform point. So instead, what I want to think about is the y for my transform function. The way I get that point is I take a and I multiply it to the y for my parent function, and I added k, right? This is what we do when we graph. Is you take your point from the parent function, you take its y-coordinate, you multiply it by a and add k to get your new y-coordinate. So I know then that -2, that's the y for my transform point, is equal to my a, which is 2, times the y from my parent function, which is 1, plus k. And now I can solve this equation for k. So 2 times 1 is 2, and I subtract 2 from both sides, I get -4 for k. And that's everything I need. Lily?
So for that one, if the y was 0, then the other one would be like k would equal the y, right?
Yes, which is what you can do in part A if you use sine.
Okay.
Is that in that one, h can just be 4 and k can just be -3, and it's very easy. Here, because we're told the point we're given is a maximum, is what makes it kind of a pain in the tuchus. Is that okay? In part A, the point you're given is a free point. It could be anywhere you want to put it. My suggestion would be to put it on the midline so you can use sine, and then h and k are trivial, right? They're just the same coordinates as the point. Okay. Jane?
So did you go through B on page 6?
Sure. Okay. So first thing I'd want to do is find my values for A, C, H, and K. Since there's no H in this problem, even though the leading coefficient isn't 1, I don't really need to factor. So my A is -1, my C is 1/2, my H is 0, and my K is -1. So I'll write my transformation map. Cx plus H, AY plus K. And then I'll take my key points for tangent. And then we'll just plug the x's into the x spot and the y's into the y spot. So 1/2 times negative pi over 2 is negative pi over 4. And anything you do to undefined just stays undefined. And then that gives me negative pi over 8. And then 0. And then that's 0 and negative 1. And then we have positive pi over 8. And then negative 2. And then positive pi over 4 and undefined. Okay so far? Okay. So now I'm going to plot my points. The pieces where the y-coordinate is undefined is telling me where my vertical asymptotes are. So I notice that each grid line is pi over 4. So pi over 8 must be like halfway. But here's my negative pi over 4, undefined. Here's my positive pi over 4, undefined. And then I have negative pi over 8, 0, 0, negative 1, and then positive pi over 8, negative 2. So there's one period, and then I just repeat everything now. So usually when I do this, I like to draw in my asymptotes first. So I'll just go and put in all my asymptotes. And then I'll fill in my other stuff. And then I'll draw my graphs in. Meow. 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 So it'll look something like that. Does that feel okay, Jane?
Yeah.
Okay.
So on the test, will we have to ever look at a graph and then like pick out points to find the equation?
Yeah.
Okay. So that's just like page 5, but just have a graph, right?
It'd be like worksheet 5, right, where I give you the graph and ask you to come up with the equation.
Okay, so that's, yeah, so you're just looking at it and saying like, oh, that's the maximum, that's the midline.
Yeah, you can do exactly that kind of thing to do
What
it.
we were doing for like the 3 that we were, okay.
Except you have more information, right? You have kind of whatever information you want to find.
Okay. Thank you.
Yep, Victoria?
On page 4, did you use like, I just don't know how to find it.
Page 4. And then you wanted to look at C, but really all you cared about was the period.
Yeah.
Is that right? Okay. So write down our values for AC, H, and K. I notice the leading coefficient isn't 1 on X, but it doesn't matter because there's no H with it. There's nothing added or subtracted, so that doesn't really bother me too much. Is that okay? Oh, sorry, C is 1 over 4 pi.
Oh, but it's like 4, 5.
So the period we know is 2 pi times the absolute value of C. So that'll just come out to just be 1/2. 2 over 4 is a half. Pi over pi is just 1. 1 times a half is just a half. Is that cool?
Yeah, if, like, let's say for V, it's like under the, like, X over 2, do you just multiply it like that?
So if you're saying that we have sine of x over 2, So that's telling me that my 1 over C is 1/2. So C would be 2 in that case. Is that what you're asking?
Yeah. And there would just be no H or K.
Correct. Yeah, A would be 1, H and K would be 0. Does that feel okay, Victoria?
Yeah.
Of course. Alrighty then, folks. I need you to find a partner. And then once you found your partner, come up and see me, and I have something for you two to work on. Who's your partner? Okay. Hi, you guys are together.
It's right on.
Okay, there you go.
But yeah.
Hi, you guys. There you are. Who's your partner? Okay.
Oh, God.
Who's your partner? Okay. Who's your partner? That was confusing. There you guys go. Who's your partner? Okay. You're welcome. Okay, so you three? Okay. Yes, let's look at what's going on
I
here.
did it with I put the multiplication sign in one and I didn't put it in the other one. But these ones are both when I transferred it to radians and I didn't get any.
One okay.
So let me just double check and let me look at the problem one more time. So we're looking at this one, right? So one thing right away is that you're missing a parenthesis.
That would do it.
You have to have that parenthesis closing it because it's going to stick the -2 under, which is not what we're supposed to. But I don't know why you're using -2.
Is that not what?
Well, that's
it's
not any of the
here.
x coordinates, right?
What's the final equation?
I'm talking about this -2. That's where the x is.
Oh, I thought you said -2.
Oh,
So that's probably my
yeah,
fault.
-6. And there's the -12 that should go with it.
Ah, thank you very much.
Of course.